As part of the 2022 BioBlitz at Falls Creek, I conducted numerous video drift marine surveys. The purpose was to both document bottom topography and marine communities. The video survey at the seawall next to the front of the now closed Edgewater Casino proved the most interesting. It is both unique in bottom topography as well as marine life. The seawall and rocky rubble in front of it was created for the 1985 World's Fair, thus has over 37 years to develop a stable marine community. The rocky substrate that you see is key to supporting benthic or bottom-dwelling marine communities. Unlike the normal silty, muddy bottom conditions found in Falls Creek, this is a perfect environment for animals that need a bottom structure to actually locate on. The rocky bottom provides conditions for the Pacific oyster that you see here to really thrive. Oysters help stabilize sediment. They provide a valuable underwater habitat, improve water quality, and are an important ecosystem foundation series. The Pacific oysters shown here prefer to attach to harder rocky surfaces in shallow water or sheltered waters. The Pacific oyster can be seen in the shells of other oysters and animals. The larvae often settle on the shell of adults. Thus, great masses of oysters can often grow to form huge oyster reefs. You can see an interesting artifact here which is dropped down, and of course we see our first Dungeness crab moving across the screen. Through this drift dive, I've only observed 2 or 3 other Dungeness crabs, so it isn't highly populated, but nonetheless it shows that they do live here and probably thrive quite well on the available food. Now as we go down to deeper areas, you'll notice that there is a thin layer of sediment that has become attached and settling on the top of the rocks. Bottom topography now, you can see much more sediment in, thus less substrate for benthic animals to attach. It's fortunate the Pacific oyster is very tolerant to both temperature and salinity changes. The Pacific oysters, they have separate sexes and spawn when the temperature is about 20 degrees Celsius. Females release anywhere from 50 to about 200 million eggs at regular intervals of 5 to 10 times per minute. Rise in water temperature is the main clue, actually, in spawning. Their larva is, like many marine creatures, planktonic. It often drifts for several weeks before finding a suitable location. This is a prime example of oysters living on oysters. You might call it the oyster condominium, and is given aquaculturists the idea of the best substrate for larvae to attach is old oyster shells. Again, you can see how they grow on top of each other, different layers. And you can also see closely the mantle, or the inside with some tiny fringes moving around to collect plankton, their main food. I mentioned before the rocky substrate, and this again is key to providing an artificial reef or a good marine community. The white dots that you see are either acorn barnacles, which are the larger ones, and the tiny clumps of white would be a type of barnacle known as a buckshot barnacle. I'll move the camera in close in some of these areas, but that's quite by accident. Since I'm towing this, I have little control on moving it to the right or to the left. Since I'm live viewing this with a second camera on the surface, I can adjust the elevation or the height above the reef, but I can't change the direction. Now you see to the right hand side of the screen a group of small fish, which I unfortunately can't identify, and this will give you an idea how green the water is. Okay, we'll again move along the bottom, dominated by, once again, the oysters. At this depth, we'll see very few mussels. We have to go up into shallower water. Scanning the rocks in the upper end of the reef, we can start seeing some algae. But again, algae are not in abundance in this particular area. The overcast, the darkness is pretty great because of the blocking of the aquabus dock, which is directly in front of the area that I'm surveying now. If you hear a slight crunch on the video, that is when my camera actually hits one of the rocky outcroppings or a group of the oysters, as you'll hear here. Again, I can't control direction, and I'm trying to raise the camera up. So we'll move to a different scene. This again, the camera was placed on the ground. I move it up slightly, and of course, we're at the mercy of the winds and the currents in the area. So we'll again continue our drift along this seawall and the rocky rubble in front of it. Of all the dozens or so areas that I have surveyed via video in Falls Creek, this is the only one that has been dominated by the Pacific oyster. In many of the areas we'll find huge mussel colonies, and we do here in much shallower water, but it's the oysters that tend to dominate on the bottom and are the primary marine species in this area. Except for the small school of about a dozen fish that we've seen previous, you'll notice there are no other fish populations observed or recorded in this area. The drift dive was approximately 15 minutes long, and again, dominated by the Pacific oyster. You notice between the rocky rubble in the area, you'll find some sand. Oh, the red thing, I believe, is a deflated balloon. What's it doing there? I have no idea. Between the rocks, you'll see a combination of crust oyster shells, crust mussel shells, some rock fragments, all of which help to provide a cover surface for the fine, silty mud that actually exists in a majority of Falls Creek. Another interesting to note is there is very few pieces of trash down here. We saw earlier one scooter that was actually probably lost by a small child. And you'll see a few sections of rope and a few pipe sections probably left over from construction, as you see in front of the video right now. But all in all, I saw no bottles, no cups, no trash. So it is a relatively pure area in terms of marine population rather than human trash. A great view of how even the ledges between the rocky sections have been occupied by many creatures. In fact, here's the second or the third Dungeness crab that has appeared, making his way through the rocks in search of food or possibly protection. But there are few predators in this area. This is a line that has been covered by filament algae. The line was down there so long it was embedded in basically an oyster condominium. Now we have another pipe, probably again left over from construction, that is part of the artificial reef.